We're going to make quite a few measurements in chemistry, and measurements are usually expressed in either the metric system or the International System of Units, which is called the SI system. There are 7 basic units of measurements in the SI system. 5 are of particular importance to us. Length, which is the meter, mass, which is kilogram, time, which is second, temperature, which is Kelvin, and quantity, which is mole. So those are the 5 that we're going to use quite frequently in chemistry. There's also electric current. We don't use that very much. It's the ampere, and luminous intensity, which is the candela. So let's look at some of these SI units. The unit for mass is the kilogram. There is an actual standard kept for a kilogram in France. Now there's a difference between mass and weight, although sometimes the words are used interchangeably. Mass is how much matter a body contains, and weight deals with the force of attraction of the earth for the mass. So weight incorporates gravity. So your weight on the moon would be about 1/6 of your weight on Earth, but your mass is the same. Mass never changes, but your weight can change depending if gravity changes. Like on the moon, there's less gravity, so you would weigh less. But since the Earth's gravitational pull is essentially constant, 9.8 meters per second squared, we're going to use the terms weight and mass interchangeably quite a bit, and that's okay. I've given you some conversions here. 1 kilogram is equal to 2.205 pounds. I don't expect you to remember the conversions. This is just to kind of give you a reference point to pounds, which we're used to. Unit of length, the SI unit for length is the meter. We originally defined the meter as 1/10,000,000th of the distance from the North Pole to the equator. Well, the meter has been redefined as 1.65 million times the wavelength of an orange-red light emitted by Krypton 86. I don't expect you to know these numbers here, so don't worry about that. But the reason they redefined the meter in number 2 is because it's more reproducible and it's also more accurate this way. So that's why we used the redefinition for the meter under number 2. A meter is equal to 39.37 inches, just to kind of give you a frame of reference to what we're used to in inches. Unit for time is the second. A second was originally defined as 1/86,400 of a day, because there's 86,400 seconds in a day. That makes sense. Now we've redefined the second as the duration of so many periods of a certain line of cesium-133. Again, I don't expect you to know this new definition, so don't worry about this definition down here, but it is more reproducible and it's more accurate. When we get to volume, there's 2 different units here. The SI unit is the cubic meter, because volume is length cubed, meter times meter times meter. But the common unit, the one that we're going to use most frequently, is the metric unit, which is the liter. A liter is defined as 1 cubic decimeter, or 1,000 centimeters cubed. Now, I don't expect you to know a whole lot of conversions, but if you want to convert from the SI to the metric system, 1 milliliter is equal to 1 centimeter cubed. So I do expect you to know this conversion right here. Unit of force, the SI unit for force is the Newton. It's a derived unit. Force is a push or a pull. Force is mass times acceleration. It's derived, which means it comes from the 7 base units, and it's a derived unit. It's equal to a kilogram times meter per second squared. So that is the Newton. Unit for pressure, there are 2 units here. The SI unit's the Pascal. That's it's a derived unit. I'll get to that. And the metric unit is the atmosphere. Pressure is the force over a unit area. So it's force divided by area. The Pascal is a derived unit from the 7 base units, and if you go back to the 7 base units, you have kilogram, meter, second, mole, and Kelvin. Here's your units for a Pascal as it is derived. The force experienced by an area exposed to Earth's atmosphere is equal to the weight of the air column above it, and this is called atmospheric pressure. When I think of atmospheric pressure, I think of the pressure pushing down, this force pushing down on us on a per unit area. 1 atmosphere is equal to the pressure exerted by a column of dry air at sea level and 0 degrees Celsius. So the conversion between the SI and the metric, 1 atmosphere is equal to 101,325 pascals. Unit of energy, there's two units here. The joule is the SI unit, calorie is the metric unit. Energy is the capacity to do work. And again, a joule is a derived unit. If you go back to the 7 base units, a joule is equal to kilogram meter squared per second squared. So all of these SI units, joule, Newton, Pascal, they can be derived from the 7 base units in the SI system. Now, chemists have traditionally used the calorie as the energy unit, so we'll kind of flip back and forth between the calorie and the joule, but here conversion is 1 calorie is 4.184 joules. In the SI system, or the metric system, units other than the basic units can be obtained by using prefixes. So here are some common prefixes and their meanings, along with their abbreviations. So like mega, capital M means 1 times 10 to the 6th. Kilo, K means 1 times 10 to the 3rd, and so forth. So I expect you to know these prefixes here. There are about 8 of them, and know their meanings. Let me give you an example. We'll do some conversions between prefixes. So let me give you an example of some prefix conversions here. Let's say I want to take 2 times 10 to the negative 6th kilograms, and I want to convert that to nanograms. Well, the first thing you need to do is you're going to start with the 2 times 10 to the negative 6th kilo. We're going to use dimensional analysis, so kilo is going to go down here at the bottom. And I'm going to go back to my base unit. Well, my base unit is grams, doesn't have a prefix. Kilo, go back to your chart, kilo means 1 times 10 to the 3rd, and that 10 to the 3rd will go in front of your base unit every single time. So 1 times 10 to the 3rd goes in front of grams, that's my base. You put a 1 in front of the prefix. Kilograms cancels out. Once I get to grams, I want to go to nanograms. So I'm at my base unit, I want to go back to another prefix, nano. I'm going to put a 1 in front of the prefix every single time, and then you put what nano means, which is 1 times 10 to the negative 9th, in front of your base unit. So the meanings of those prefixes always precede your base unit. Then it's just a matter of doing your math. 2 times 10 to the negative 6th, multiply by 10 to the 3rd, divide by 10 to the negative 9th to get your answer in a new prefixed unit. So if you have your calculator, you can check that to make sure you get the correct answer there. Let me do one more. Let's say we have 33, let's say centiseconds, and I want to go to microseconds. So I'm going to start what I'm given, put it over 1 to show it's in the numerator. I'm going to cancel units, so centiseconds is going to go on the bottom. I'm going to go back to my base unit. Base unit has no prefix, so that's just seconds. You put a 1 in front of the prefix. What does centi mean? 1 times 10 to the negative 2. That goes in front of my base unit, which this time is seconds. And I'm going to go to microseconds. So we're going to put seconds down here, microseconds up at the top. You put a 1 in front of the prefix, which is micro. And then what does micro mean? 1 times 10 to the negative 6th. So you'll notice when I'm doing these conversions, if you have a prefix, you put a 1. And I always go back to my base unit before I try to go into another prefix. 33 times 1 times 10 to the negative 2 divided by 1 times 10 to the negative 6th. Again, if you have your calculator, make sure you can get these entered correctly and get the correct answer. But you would get 3.3 times 10 to the negative 5, and that would be microseconds.